Hello everyone, myself Dr.N.B.Wadwale, Assistant Professor at MSG College Malegaon district Nashik. Today we have to study about the phase equilibrium chapter from physical and analytical chemistry. Topic is water system. First of all, we have to study about the phase diagram. Phase diagram which shows the condition of equilibrium between the various phases of a substance is called as a phase diagram or the equilibrium diagram. The graph of the variation of vapor pressure of a liquid with temperature as shown in the figure below. There, the diagram it can be indicating that the phase diagram is dependable onto the vapor pressure and the temperature. The curve AB shows how the vapor pressure of the liquid changes with the temperature. Along with the AB, the liquid and its vapor coexist in a state of equilibrium. To describe the system completely, either pressure or temperature need to be fixed and the degree of freedom is 1. Below the curve AB, only one phase, namely the vapor of the liquid, exists. To describe the system phase, namely the vapor of the liquid, exists. The describe the system in this area, two variable pressure and temperature must be specified. Above the curve AB, only liquid phase exists and describe the system under this condition. Again, temperature and pressure must be specified. From point Y to Z or from point Y to X, the pressure is changing at a constant temperature. At Y, a state of equilibrium between the liquid and its vapor exists. As pressure increases above the vapor condenses. When all the vapor condenses, a liquid phase is obtained in the system Z. When the pressure is reduced below point Y, the liquid boils and gets converted into its vapor. When all the liquid is vaporized, only the vapor phase is obtained in the system, that is the point X. One component system. We have to know about that. One component system is the chemical composition is a single throughout the system, but different phases are present. A system in which the chemical composition of every phase can be represented in a single substance is called as a one component system. For example, water system and the sulfur system. The number of phases which can exist in the equilibrium depend on the conditions such as the temperature, pressure and composition, etc. These conditions are determined experimentally and summarized in the pressure temperature or temperature composition diagram is called as a phase diagram. So the water system, the temperature above 20 degrees Celsius and pressure below 200 atmosphere. Within these limits, only one solid phase for water is possible, namely ordinary ice. Below the temperature of minus 20 degrees Celsius and above 200 atmosphere, pressure other modification exists. So description area A, the diagram indicating that there are the three phases, that is ice, water and water vapors. That ice phase is the curve OC that can be indicating the phase of ice curve, and curve OB indicating the water curve, and curve AO indicating the vapor curve. So diagram is divided into the three areas. The the to the left of the curve OC and above the curve OA, the area AOC water exists only in the ice. Area AOC water existed into the ice form. To the right of the curve OC and above the AOB, the area COB indicating exist as a liquid phase of the water, and the below the curve OA and OB areas AOB only water vapor exist in the system. So this is the three areas of the system is a bivariant and both have the pressure and temperature must be specified. So description for the four curves, that is the curve AO, it is formed by the intersection of the areas in which the water exists only as ice and vapor respectively. The curve represents the sublimation curve of the ice. Along the curve, ice exists in the equilibrium with its vapor. Ice has characteristic vapor pressure at a different temperature. The system is a monovariant. And to describe it completely, either pressure or temperature must be specified. The curve OB, it is formed by the intersection of the areas representing the liquid and vapor phase of the water. The curve represents the variation of vapor pressure of the liquid water with temperature, and along the curve, liquid water exists in equilibrium with its vapor. The system is a monovariant. The curve extends from O to the critical condition of the water TC, that is 374 degrees Celsius, and PC, that is a pressure, this is 220 atmospheric pressure. The line OC, the curve OC, it is formed by the intersection of areas representing the solid and liquid phase of water. The curve represents the variation of melting point of ice with the pressure. Along the curve, ice exists in a state of equilibrium with the liquid water and the system is a monovariant. The slope of the line is negative, indicating that the melting point of ice decreases with the increase of pressure. Increase of pressure lower the melting point of ice according to the Lee caterpillar principles. So line CO runs from the point O up to the point corresponding to at 200 atmospheric pressure and above the 20 degrees Celsius temperature. At this point, ordinary ice in equilibrium with the water undergoes for a transformation into the another solid form in the equilibrium with the liquid. So the dotted curve OD, the curve represent the metastable equilibrium between the liquid water and water vapors, liquid phase, water phase, and the vapor phase. The curve, therefore, is an extension of the curve OBO along the curve liquid phase exists below its melting point. Without the separation of solid phase at each temperature, the vapor pressure of the liquid is greater than the expected equilibrium pressure for the ice, thereby representing the metastable state of the system. The system is a monovariatal. Triple point, the curve AO, OB, and OC all intersect at the point that is a O. At a triple point O, there are three phases of water, namely ice, liquid, and vapor, coexist. That is a state of equilibrium. That is a state of equilibrium point. That is O or triple point. According to the phase rule, the system is non-variant. Thus, the three phases coexist in the state of equilibrium at a definite temperature and pressure. That can be explained into this diagram. That is a degree of freedom is a one for the liquid state, that is univariant. Solid phase, it is a divariant, that is solid and liquid, and the univariant for the vapor pressure diagram. So this is the uses of the phase diagram. Into the areas A, O, C, ordinary ice, solid phase, degree of freedom is a 2, pressure and temperature system is a variable. That means number of variable are utilized, that is the pressure and temperature. In the area COB, liquid water is present, degree of freedom is a 2, pressure and temperature system is a bivariant. Area below the curve AOB, vapor pressure, vapor phase, that is gaseous phase, degree of freedom is a 2, pressure and temperature system is a bivariant. The curve AO, solid to the vapor, the degree of freedom is a 1, pressure or temperature system is a monovariant. That means only one variable can be utilized and the system is a monovariant. The curve OC, solid to the liquid, degree of freedom is a 1, pressure or temperature system is a monovariant. Curve OB, liquid to the vapor, degree of freedom is a 1, pressure or temperature system is a monovariant. The curve OD, metastable equilibrium, liquid converted into the vapor, is super cool, that is the degree of freedom is 1 and the pressure or the temperature of the system is a monovariant. Triple point O, solid, liquid, and vapor, degree of freedom is a 0, that is the system is a monovariant. Thank you.